Hi everyone. Hi, this is Hang, Ashish, and John here. So here we present our experiment for classifying and to identify Twitter accounts to see if they're bots or not bots. We have a high motivation to do this because in a recent research conducted by University of South California and Indiana University, they found out that about 48 millions of Twitter accounts are actually non-human, so they're bots, and which is actually the 15% of the total Twitter populations. We see that the bots actually have great influence to distribute different kinds of information. A lot of people using bots for good cause, and also we identify that some bots actually malicious to spread different kind of information that may be harmful for people's reputation and or manipulating people's decision on decision makings, especially. On November 1st, 2016, Atlantic actually had an article about how Twitter bots has shaped the 2016 U.S. president elections. So, it's actually bots had done a lot of direct or indirect influence on people's decision making on their voting. That's why we want to have identify who are the malicious bots. But at the first step is identify the Twitter account to see if they're bots or not bots. These are the four related works that have used as a references. So they actually help a lot to guide us how to do this project and experiments. And the next step is John will talk about how we do the data preparation and the feature engineering. Thank you, John.
So the dataset we used was an extract from the Twitter API, which originally had 130 attributes. Among these, we extracted 20 and used feature engineering to extract new ones, such as the age of the account, the length of the screen name, whether the word bot appeared as a substring of the screen name and the description, the polarity and subjectivity of the description, and the probability of the user being male or female. For naive Bayes, we used only the description attribute, and for logistic regression, we used 4 of the user's social statistics. For decision trees, we used 9 features, which were the age of the account, the length of the screen name, the occurrence of the word bot in the screen name and description, and the rest of the social statistics. For random forest, we used the same 9 features, as well as the polarity and subjectivity of the description. And now Ashish will tell us about how we use naive Bayes.
Let's start with naive Bayes classifier, which provides a nice baseline for this task. Bag of words representation of description attribute is used for naive Bayes model. We split the given data into 2 datasets, which is one training dataset and another one is test dataset, which concludes the 20% of the total dataset. For evaluating the performance of classifier, count vectorizer and TIFDF transformers are used for training and test data. From this, we get frequency of words in description column, which we get through tokenizing strings and giving an integer ID for each possible token. And second one is counting the occurrence of tokens in each document and weighting with diminishing importance tokens that occurs in the majority of samples or documents. By this, we get the accuracy of 76.95. To increase the accuracy, we start with logistic regression, and Heng will introduce with that.
So we try logistic regressions. This is a very funny name because your order is in regressions. Actually, it's a very good model for classification problems. That's why we use it here. So at the first attempt, we use the default settings from sklearn. So we use all the numerical and binary features. So at the first attempt, we got the training accuracy and test accuracy as 70% and 72%. This is actually not good enough compared to what we already had from naive Bayes. That's why we should have another second attempt. In our second attempt, we examine the coefficients to evaluate the weights of each features. So on the right-hand side, you see a table. On the left column is all the features listed here, and the right column is actually all the coefficients represented by the features. So we pick all the features that has positive coefficients, which are highest. So in this case, we pick the follower count, friends count, favorite count, and status count. In this, we help us to get the accuracy jump up to for training accuracy is 75% and test accuracy is 72%. However, we still found a better result. That's why we move on to use decision tree. So John will talk about decision tree here for us.
So decision trees classify examples by creating branches based on the feature values and feature importance. Among the 20 features we chose from the original dataset and the ones that we engineered, the classifier would only accept those that were numerical and binary. And among these, we only used those with a significant feature importance. The tree ended up yielding an accuracy of about 88.3%. And now Ashish will tell us about how we used random forest.
After using classifiers such as decision trees and logistic regression to calculate the accuracy on test data, we proceeded with the random forest on which we have high stakes for the accuracy. Random forest is an assembled learning method for classification, regression and other tasks that operate by constructing a multitude of decision trees at training time and outputting the class that is the mode of the classes, that is classification or mean prediction, that is regression for the individual trees. In the random forest, we use three parameters. First one is n estimator, which we have kept as to be 200, as it diversifies our trees and accepts all the scope of classifier. The second one is OOB score, which means that we have to use out of bag samples or not, and we have kept this as the default value, and which is a boolean false, and we are not using the out of bag samples. Third one is a criterion. In this parameter, we have chosen criterion to be entropy, which give us the information gain of the attributes we have calculated in the decision trees, and for this it gives the quality of the splits. For the results, Heng, will you explain why we choose random forest?
Thank you, Ashish. So as we can see that a random forest classification gave us the highest accuracy score, and also in here that RC curve also for all RC curve for all the models we did also provided visualizing the evidence showing that random forests have AUC 97.6%. That's why we gonna use random forest, the result from random forest, for our first attempt on a Coco competition. On the first attempt, we already got 97.213%, which bring us to the 10th place in the competition in the first attempt. And on the next few attempts, we tried to use data preprocessing, rescaling. We even did settlement analysis and gender detections on the data. Additionally, we also try to use different combination of features and different combination of parameters for random forest classification. However, although in local testing, we had the highest 93%. Unfortunately, when we submit into Coco competition, we still stick with our highest score we had, which was 97.213%. So although we didn't make a lot of progress in the Coco competition, however, we did a lot of analysis on our IPython books. So if you want to look into for more details, please go to our GitHub links, so you can see what we have done for the analysis. So next, John will talk about the evaluation for our project.
So what went well for us was using the sklearn, NumPy, and Pandas libraries to clean up our data, engineer features, and classify examples, as the functions made available to us made these tasks rather easy. What did not go so well was a portion of the feature engineering, like getting the precise age of the account, since only the years were unambiguous. There was another feature called status that might have improved the accuracy, but we had to discard because the format was simply too inconsistent. Also, we found that most of our enhancement attempts, like the gender detection and sentiment analysis, did not make any improvements of the accuracy. If we had more time, we would have tried different libraries for our feature engineering and experimented with TensorFlow as an alternative machine learning library. So in conclusion, the random forest classifier had the highest accuracy and demonstrated that there are measurable differences, feature-wise, between bots and human users, which suggests that it's a feasible goal to distinguish between them and detect malicious bots, which was our original motivation. And now Heng will give us his closing statements.
Thank you, John. So we are very thankful and have this opportunity to do this experiment to identify Twitter account to see if they're bots or not bot. We believe that is actually a very initial step to find out the malicious spots, because we see the harmfulness, we see the impacts of fake news and fake information spreading. So we hopefully in the next in our future attempts, we're going to further polish this project so we can help to contribute to identify malicious spots. So thank you so much for your time for listening to our presentation, and hopefully you have a great day. Thank you. Bye bye.